Now we're going to look at the final type of measurement of line segments and the final type of center of a triangle that we're going to study this year. This next thing is called the altitudes. An altitude of a triangle is a segment from a vertex to the line containing the opposite side, meeting at a right angle. Every triangle has 3 altitudes, which meet at a point called the orthocenter. So this is our fourth center. Right, the altitude of a triangle. In our triangle here, ADB, the altitude from the vertex D to the side AB is this line right here, DC. You'll notice that it's outside the triangle, so it is possible for your altitudes to be outside of your triangle. On triangle FEH, EG is the altitude from vertex E to side FH. And then we've got a couple other segments over here. Sorry, a couple other examples. On this one over here, this is kind of a noteworthy one. Triangle KIJ. The altitudes of this one, it's got 2 of them actually on here on the picture. On a right triangle, each of the legs of the right triangle is actually an altitude of that triangle from the vertex from the vertex K to IJ and from the vertex J to IK because they do form that right triangle. Things that are not altitudes of triangles are this one here. This one displays an angle bisector. You can tell because they show you that each of the small pieces of the angle here are congruent. This one over here, it's going from the vertex to the midpoint of the other side. So this one is a median. I should have put that on here. So this one was angle bisector. And this last one over here, that's just going from one side of a triangle to another side of a triangle. That's not an altitude. An altitude has to go from a vertex to a side of the triangle. Alrighty. Okay, with various types of triangles, we have different situations. If you have an acute triangle, which as a reminder, that means all 3 of the angles are acute, then the 3 altitudes will be inside the triangle. So all 3 of your altitudes on this one would be inside your triangle here. There we go. And so this would be our, this would be our orthocenter for this one. If you have an obtuse triangle, 2 of the altitudes are going to be outside of the triangle and only 1 of them will be inside the triangle. So when you have this obtuse triangle here, this is the altitude from this vertex to the bottom side over here. The one from the obtuse angle to the other side, that's going to be the one that's inside of your triangle. And then the third one would be from this angle, and it has to go over to this side and be perpendicular to it. So for this one, I would have to extend this side also in order to draw in that altitude. Now the point of concurrency for all of these is actually going to be way, way outside this triangle. I would have to extend all of these so that they would meet, and that would be my orthocenter. In a right triangle, 2 of your altitudes are the legs, as I mentioned before. So this would be an altitude from this vertex to this side. And this would be an altitude from this vertex to this side. And then the third altitude, the third altitude would be inside. I did not draw that right at all. Wow. Okay, so the third altitude would be inside the triangle here. There we go. For this one, the point of concurrency of the 3 altitudes is actually the vertex at the right angle. Okay, so here are a couple of drawings. With an acute triangle, the orthocenter is inside the triangle. With a right triangle, the legs of the triangle are two of the altitudes, so the orthocenter is the vertex of the right angle. And if you have an obtuse triangle, this is a little bit hard to see on this picture, but anyway, this is your obtuse triangle here. The orthocenter is actually outside of the triangle, so this would be the orthocenter way out here. All right, so we have an example of finding the orthocenter on a coordinate plane. So to do that, we've got the vertices of a triangle given. That's at 1, 3, 7, 7, and 9, 3. And they plotted those for us, 1, 3, 7, 7, 9, 3. And they want us to find the coordinates of the orthocenter of triangle ABC. So in order to do that, I would need to draw in the line segments that are from one vertex and perpendicular to the opposite side here. So in order to get that correct, I need to remember the relationship between the slopes of perpendicular lines. So let's see, the slope of line segment BC here is 1, 2, 3, 4, 1, 2. So 4 over 2, and it's negative. So the slope here is -2. So the slope of a line that's perpendicular to that one would be the opposite reciprocal of that. So that means the slope of this line here would have to be a positive 1/2. So let's check it out. From this point, if I go up 1 and over 2, up 1 and over 2, up 1 and over 2, it does give me points along that line. I'm going to do the same thing for the next one that they drew in here, and then we're going to draw in the third one as well. So this line here has to be perpendicular to AB. So I need the slope of AB. So I'm going to count it off. From A to B, I would be going up 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6. So the slope on this one is 5 over 6. 1, 2, 3, 4, sorry, 4 over 6, which is 2/3. So the slope of this line here should be the opposite reciprocal of that. So the slope on this one should be -3 over 2. So let's start from this point here, and then we're going to count off that slope and see if it matches up with points on the line here. So for this one, since I need to go up and to the left here, I'm just going to move the negative to the denominator. So I'm going to go up 3, 1, 2, 3, and to the left 2. And do it again, up 1, 2, 3, and to the left 2. So that does give me points that are along that line there. So I've got one more line that I need to do that with. Let me pick a third color. I think I will do this one in green. So I need a line that's perpendicular to this line segment here, and it needs to go through this point. So the slope of this line here is 0. The opposite reciprocal of a slope of 0 is undefined. So I need one that goes through this point that has undefined slope. Now, undefined slope is just a vertical line. So I'm just going to draw in a vertical line here. And you can see the point of concurrency here is where all three of them meet. And so we just need to state the coordinates of that point there. So if I count them off here, this point here is at 9, 3. So this would be 8, 7. And then up 4, 5, 6. So 7, 6. So coordinate plane, very helpful in finding that. All right, so there's one more problem here at the bottom. We're given the coordinates of the vertices of the triangle. So this time we actually have to draw in our triangle first, and then we have to find the altitudes so that we can find the orthocenter. So take a moment and pause the video and see if you can draw the triangle first. Okay, hopefully your triangle came out looking somewhat like mine. If it didn't, Go ahead and pause the video again, erase, and give it a try, retry. All right, so now I'm going to go through finding the altitudes of this triangle. So the first altitude I'm going to find is from point S to UT. And so to do this, I'm going to need the slope of UT. So I'm going to count that off. I'm going to go from the endpoint to the endpoint because I don't trust my line here is perfectly straight. So I'm going to go ahead and count up 1, 2, 3, 4, 5, 6 up, and 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So up 6 over 9 would be a slope of 2 over 3. So the slope of the altitude from S to this line would have to be a slope of the opposite reciprocal of that, so negative 3 over 2. So I'm going to start at this point here, and I'm going to count down 1, 2, 3, and to the right 2. And then do that again, 1, 2, 3, to the right 2. And then I'll connect those. It drives me crazy that it moves my stuff. Anyway. Okay, so try that again. So I'm going to connect these. And I know that that's making a right angle here because I used a slope that would create a perpendicular line. Okay, now I need to do that with at least one more. I'm going to go ahead and do all 3 of them though, just to be sure. I'll do my next one in green. So for this one, I'm going to be going from U to ST. So in order to get the line that's perpendicular to ST, okay, so I'm going to count, find the slope from ST here. So I'm going to count from S to T. So I'm counting, it is negative. I know it's going to be negative. So I'm going to count down 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5, 6, 7. So that would be a slope of negative 4 over 7. That one doesn't reduce. So the opposite reciprocal slope on that one would be 7 over 4. So I'm going to start from this point here, and I'm going to do a slope of 7 over 4 in order to find my perpendicular line. So starting at this point, I'm going to count up 1, 2, 3, 4, 5, 6, 7, and to the right 4. 1, 2, 3, 4, which gives me a point of concurrency already. If I do it again, 1, 2, 3, 4, 5, I'm going to fall off the graph here. So I'm just going to go ahead and connect those two to make this altitude. I know it's perpendicular because I designed it that way. I used the opposite reciprocal slope. Now I don't actually need the third one. I can actually find the orthocenter right now. I can tell that it's 4, 5. But it's really good practice to go ahead and find the third one just for the practice. Practice is always a good thing. So let me pick a different color, maybe that one there. Okay, and this time we're going from point T, and then it needs to be perpendicular to SU. So I need the slope of SU. So again, I'm going to count from endpoint to endpoint. It is positive, I can tell because it's going upward. So if I go from U up to S, that would be up 10 and over 2, which reduces to 5. So the slope of the line that I'm going to draw on this one has to be opposite reciprocal of 5. So that would be a negative 1/5. So I'm going to go from this point. Let's see, I'm going to go down 1. Nope, I'm going to go up 1 and to the left 5 so that I'm approaching where I know it needs to go. I know it needs to go to this line over here. So up 1 to the left 5. 1, 2, 3, 4, 5. Again, that gives me my point of concurrency there. I could do it again. Up 1, left 5. 1, 2, 3, 4, 5 here, and then connect those. And that's my third and final altitude. And so I could draw that in. And again, I know it's perpendicular to this side over here because I use the opposite reciprocal slope. Alrighty, so that's how we find the orthocenter. It can be done algebraically also, but that's a much more in-depth process. Using the coordinate plane is much easier.